Hello everyone, I'd like to use 3 videos to introduce the communication between YASKAWA MP3300, this motion controller, and Allen Bradley and Siemens controller. This is the 3rd video, and in the 2nd video, MY02 video, I showed this case. I used the Siemens S7-1200 PLC run as PROFINET Master, and MP3300 run as the PROFINET I/O device. To run this case, we have to purchase one additional board, 266F-02. This is the YASKAWA one additional board. Allows this MP3300 run as PROFINET, this protocol. In this case, I will show one cost-effective way. Then this row will be backward. So in this case, MP3300 will use this built-in port. This is the EtherNet EIP Master. And then Siemens controller will run as EtherNet IP adapter. I know it's rare to see the Siemens controller can run as Ethernet IP adapter or device, but definitely I will show how can we use this. As we can see the current hardware here. So the Siemens side, I'm using S7-1200 PLC. This is standard S7-1200 PLC. Or if you are using the S7-1200F, the safety built-in controller, the method, they are the same. And in this case, the YASKAWA side, I'm using MP3300iec. So we could implement the Siemens side run as the Ethernet IP adapter function. And the MP3300, this motion controller, using this built-in port, the Ethernet IP can run as a master. So we do not need to purchase this additional hardware. So we only use the built-in function from this MP3300 and communicate with the Siemens. Also the Siemens side, to implement the Ethernet IP slave, the adapter function, there's also no any cost. We just need to download one library, one existing function block, just need to implement in minutes. Then we can set up this communication. Okay, let's shift to the engineering platform and let me show how can we do this. So firstly, we need to go to the support.industry.siemens.com. Let's download one example to allow the Siemens controller S7-1200 or 1500 PLC running as Ethernet IP device. So like showing this diagram, the Siemens PLC now they publish the Ethernet IP master and adapter features. This example shows how can we do the Ethernet IP adapter, basically the device, the slave function. So in this case, we will do this way. Typically, in this case, I'm using 1200, this controller, and I will use this function block. We can directly use this example project. Okay, and I'm using TI Portal version 17, so I can download this version 17. You can browse this ID 1097823115. Okay, let's download this example. And let's firstly implement the device side, because the device side will provide us some instant ID, the assembly number, the input and output ID number from there, and the configuration number. So once we implement the device side, this will be very quickly and easy to do something to match the configuration from the YASKAWA side, the MotionWorks, that software. Okay, let's download this example program. Alright, after we download this example program, it named demo_Ethernet adapter version 17, and let's unzip that. Then you will see this project. This is a zipped project, so we need to open the TI Portal version 17 and open this project. And then let's browse this zipped project. Let's unzip that first and select the folder. We need to unzip this project. Okay, we unzip this project. You will see there are 3 sub-projects in this entire project. When we implement the 1200 PLC, so this is the adapter, the example project. If you are using the 1500 PLC, then you can use this example. So this name has a little bit confused, but when you open this program blocks, you will see this program provide you to the Ethernet adapter feature. So while you are using the 1200 PLC, you can use this, but for the 1500 PLC, you can use the 2nd project. Okay, and the 3rd project, this one, this demonstrate if you are using the Siemens IPC, the software controller, then you can use this program. Okay, so in this case, I'm using the 1200 PLC, so I can delete this firstly. Only uses a 1200 project. And now let's go to the hardware. Firstly, I will replace this controller to the controller I'm using. So in this example project, it is using this 1215 controller. But as shown in my video at the early beginning, I'm using 1214 AC/DC relay. Okay, and I can pick this version 4.5. Okay, and because I'm using version 17, so I can go through those security settings. Basically, I will open everything. Okay, we don't care about the security now. And in the meantime, I can rename this project. This is the adapter MP3300. Okay, this is this project. Okay, save. All right, and then let's change the IP address setting. So click this port and change the IP address. So my hardware IP address is 192.168.174. Okay, 174. Okay, so we only need to set the IP address. Then the key portion, we need to look at the program. So this project provides this example. So firstly, all the program are called by this OB30. This OB30 is a cyclic OB. So as we can see, its set cycle time is 10 milliseconds. So that means the fastest time to scan this example function block, this function block is the IP1. This is the 10 milliseconds. Usually I will recommend do not need to set lower than this. Basically 10 milliseconds or even 20 milliseconds, it will be a nice setting for those communication. After all, for this small PLC, this add-on function block is an add-on feature, right? So if we set it too high, basically your controller will pay a lot of efforts on those communication rather than on its control task. Okay, so leave this 10 milliseconds here. And then we will see this EtherNet adapter. This is the function block to implement this EtherNet IP adapter feature. And this 64 that actually come from the hardware to allow this function blocks knows which hardware is using. So the hardware that actually come from this port. So this port, if we open here, system constant, then we can find, so the port represent this Siemens port, this Ethernet port. This is the 64, okay? This is the hardware ID number. So that's why for this function block, hey, this function block, you need to communicate via this hardware port, okay? And then we will see the system automatically provide this adapter data, this DB. So where is this adapter data? We can right click the go to and the definition. So we will see this actually the DB1. So this example provide us 64 bytes. This is the S integer, short integer bytes basically means. So for most of cases, this 64 default, that's enough. Or if you think this will take too much room, so you can shrink this to 31. 0 to 31, that means 32 bytes, right? Or even higher, 0 to 127, that's the 256 bytes. So the maximum, that's around 500 bytes. You can look at the manual from the example, but basically for most of cases, 64 bytes, that's good enough. So it provides us the output, input, and the configuration. Okay. We better look at this and click this small button here. Then you will see this number, the input assembly number, output assembly number, and the config assembly number. Those numbers need to match with your EtherNet IP master. Okay, this is very important here. And for this enable, we can give a command. For example, I can use M100.0. Okay, I can call this exchange enable. Okay, that's it. Now I can download this controller now. And again, the system provide us this buffer and this assembly number here. Okay, and now I can download this controller. We will firstly download this Ethernet IP adapter, implement this Siemens side at first, because we need to know those assembly number, right? Okay, let's download. Consider as a trusted device, okay? Okay, let's download. Stop all. All right, let's click the start module. Okay, after we download, we will see currently this CPU shows green, no any fault. But it doesn't mean now it's communicating, because firstly, it's waiting for us to enable this bit. And second, it's waiting for the master now. So we haven't configured this motion controller, this YASKAWA motion controller. So now let's shift to the MotionWorks, the platform, and I will use this 1.10, this IP address to connect this controller and configure this built-in Ethernet IP running as a master function. Okay, let's shift to the MotionWorks. The software what I'm using, this MotionWorks IEC3 Pro. Okay, and it has 30 days trial license. Before you purchase the license, you can use this 30 days for practice or for testing purpose. Okay, let's open a project. And let me create a new empty project now. Okay, so I'm still using the trial license. I will click this use trial and create a new project. After it open, let's create a new project. So I can click this MP33 template. Okay, I'm using this 33 IEC controller. And after we create a new project, I will recommend click this save as to save this project at first. Now we create this project. Then the first things we will do, let's click this launch hardware configuration. So firstly, we need to know how can we connect this software to the hardware, right? This is the default configuration from your template project. So this setting, you need to tell the software what the IP address from this controller. The default IP address from the MP3300, that is the 192.168.1.1. Okay, and in this case, I can click this. For example, if this is the first time to log in into this controller, then you can use the 1.1. In this case, I changed the IP address already. And then keep in mind here, the user, you need to log in and using the admin as a username. A is a capital. And the password, that is the capital MP3300. And then log in. And then let's go to the Ethernet config, this option. And from here, you can set the IP address. After the set, don't forget to click save and also click this reboot the controller to refresh your IP address. Okay, so now my controller IP address is 1.10. Okay, I can close it. And from here, I can click the 1.10. Okay, select the 1.10. Now let's click this connect. Okay, if this is the first time for you to connect this project, it will show you the left side, this is your offline configuration. And the right side, this is your real hardware. At the early beginning, the first time when you connect the hardware, so you can click this use startup configuration. This allows you to read the real configuration from your existing controller. Okay, so we can click this startup. And then we can click this save configuration to transfer those settings to the controller. Okay, to match. And then click this reboot the controller. So let's click this reboot. We need to wait for 1 or 2 minutes. Okay, now let's click this connect again. So once your offline online configuration they are matching, then the system will not show the comparison that window anymore. Okay, now we could shift to the offline. Okay, this is up-to-date offline configuration now. And we can go to the EtherNet IP here. The top frame, this window, that represent using the MP3300 running as Ethernet IP adapter. But in this case, we are going to use the MP3300 running as Ethernet IP Master. Then we will focus on this area. This area allows this Ethernet IP running as the master. Okay, so at here, let's click Add Adapter Device. This tell this master, hey, there's one device or multiple other devices you need to communicate. And then we can click this EIP slave. We will use the generic file for this system. Okay, click Finish. And here we can set the IP address. So in this case, the IP address is a Siemens controller. That's the 192.168.1.174. And click OK. All right, so we configure this IP address. So we configure this Siemens card. This is the Siemens controller 1.174. Then the system will create this. This makes sense. So once we set up one device, then next things we need to tell the system what assembly ID number we need to configure. Then if you recall from the Siemens side, so the input assembling, that's the 101. This input represent from the master side. So for the master side input, we can directly set 101, 102 for the output, and then 104 for the config assembly. Okay. Once we shift back to the motion works here, let's configure this I/O and configuration assembly. Okay, let's click this. So the first one, the input instant, this is the 101, and the bytes, that's 64 bytes. Okay, and update interval, so we can set 10 milliseconds. Okay, that matching with the cycling time from the Siemens side. So let's do this 10 milliseconds. And let's try this communication after. Okay, and we can set this point to point doing the unicast. Okay, all right, let's click Add. And then next one is the output. So let's click this output assembly number, that's the 102, and bytes, that's a 64. And update time, let's set the same, so 10 milliseconds. Okay, click Add. 101, 102, 64 bytes. And then let's move to the configuration assembly. Let's click this Add. And the assembly number in this case, that's the 104 assembly number. For the size, basically, as long as you set not equal to 0, that should be fine. So usually I will set the same length as the input and output. So in this case, I will set 64. Okay? Okay, 64 right here. All right, so we configure this, and now we can click the Save and click this Connect. And the system will find, okay, this is our offline configuration, this is the online configuration. They are now matching 100% because we just configured this, right? So this time we can click this, use offline configuration. All right, we click the Save again. And the system will ask us to reboot. So let's click this Reboot controller. Let's reboot. Then those new configuration will be implemented to the MP3300 controller. While it's reboot, we can go to the global variables here. Let's shrink this system variables. And we can see for the Ethernet IP adapter feature here, and keep in mind this is the variable ranges because we are opening that's 64 bytes, so we can see the range, that is the 64 length. Okay, and now I can create the second. So this area, we can create a variable represent the input. The input here, that means from the adapter Siemens side to the MP3300. So I can change the name to a better name, for example, the EIP status, right? So this is a 1200 to MP and 01. And we can set a bytes or a word. So I can set words, for example. So the first word, that's IW. The first byte, that's the 93792. Okay, we can set 93792. And keep in mind the number represent the bytes. So the next one, if the next one is the word still, so the next one, this is the percent IW93792344, 2 bytes. Okay, and let's rename this to 2. Okay, 2 words at here. Okay, and then for the direction from the MP, the master, to the adapter, then we can create the variables under here, paint a variable at here. This is from MP to S7-1200. So 01, we can set 2 words. Okay, QW. So the first byte, 93792. 93792. Okay, I forgot this percent, this syntax. And next one, words, 2, 3, 4. Okay, and also I can set another 2 bytes append. Then this bytes will be 4, 5, 6. Okay, and next one, the 4 byte, and the next byte will be 97. Okay, so 97. Okay, we configure everything, and now let's click this make. Okay, no errors now. So now I'm gonna download this controller, and let's click this project control dialog. So let's firstly stop this controller and click this download. Okay, after download, click this warm start. All right, so everything shows good, and we can click this debugging, and we will see the data here. So let's firstly set something here. For example, for this hex mode, we can set AABB. For example, double click and click this hex, and we can set AABB 16 pound AABB, right? Okay, AABB. Double click and click CCDD for the next word. Okay, and for these 2 bytes, we can double click. For the bytes, I can send 12, for example. 12. This is the hex 12, and 12. This is the integer word. Translate to the hex. Let's go to the 0C. Okay. For this one, I can change to the 16. 16 should be 10 on the hex. Okay, 16. So I'm selecting, and this is the decimal. I can click the. Okay, the decimal. Okay, here the monitor, this value display that represent the display at here. But when you read the data, you need to tell the system default this is the decimal. If you are going to change the hex value, you need to type in the 16 pound and write AABB, for example. Okay, so we prepare the data at here, and now let's shift to the Siemens side. And let's see the Siemens side can receive those data first, because this is direction QB at the MP side. That means we are going to transfer those data to the adapter side. Okay, so let's shift back to the Siemens side. All right, the Siemens side is here. And now let's firstly enable this communication. Let's click this monitor and modify to 1. Okay, so we will see it enabled, and it shows valid and busy. So valid basically means this slave, this adapter found the master, or means master and this adapter, they are communicating. So if now I disconnect this cable, shows false, right? The block is still busy because it's trying to search in the master, try to match the Ethernet IP communication, but it cannot do that. So the code shows 7002, and this value shows false. But if I connect this communication again, we'll see immediately the value turn true. It can recover. Okay, this is also a good test. Say if in case communication cable drop, and if the cable return again, if this communication can recover by itself. We will see this assembly number, right? And this is the buffer for input output. And then we can go to the input and the output. The input and output, they are at this DB1. So to monitor the DB1, we can double click this DB1, click this monitor, and open this output and input. We'll see it has data already. But some cases, monitor here is not quite easy because it has too many data at here, right? So then we can use the Siemens this watch list here, add a new watch list. And we can drag those output. Let's drag the first 10 output. And we can right here and drag the input. Monitor. We need to take care of one thing here. The output and the input to the name. The output actually that represent from the master to the adapter. This you need to be very carefully. Okay? So for the master, the data transferred to here, that's at the output. Okay? And the data looks weird. That's because the date type we need to change to the hex number. So we can drag here. And if you recall, so we send AABB, and keep in mind this low and high bytes here. So because from the master side we sent AABB, but the 0 actually at the right side, and the 1, the high bytes at the left side. So you need to be carefully about this low and high bytes for the word transfer. Okay, we send the AABB, CCDD, and the 0C and the 10. This hex number. Okay, and now this time we can send the decimal value from this 1200 side transfer to the master, transfer to the MP33. So this time let's send some integer data. For example, 123, 98. The reason why I wrote 98 at here, that's because the master side we send every tag represent one word. So the first word, that's this. The second word, this is this. Okay, that's why the next word data I need to start from here. Okay, keep in mind this. Now let's click this transfer. Then I transfer this 123 and 98. Now let's go to the MP side. Okay, the MP side, we need to click this login again because I disconnect the cable. And here we will see, okay, it received this 7B and 62. So this is the decimal display. We can double click here and select the standard or select the decimal. Then the display can change to the decimal. So we will see 123 and 98 we received here. And keep in mind all those address need to match, which is here. So the name actually doesn't quite matter, but we need to map the name with the IB, IW, or ID from this Ethernet IP, this buffer data. Okay, now all the things is communicating. So that's all for this video. So using this configuration from this hardware here, so we configure this Ethernet IP adapter, and we configure this configuration, this number 64. Usually I will match this 64 together. And keep in mind the input and output, they are 101, 102. Okay, if I click this online, so everything is matching, so it doesn't show any difference. And from the Siemens side, and we will see we need to enable this communication. And 101, 102 that represent the input and output. And also the data input and output showing here that actually represent the master. So the master receiving buffer that actually you need to send from here, send to the input buffer. That represent the master side receiving this data. Okay? And also keep in mind here, the update interval output and update interval input here. We will see this is the actual data cycle time. and even we set 10 milliseconds. But for this update interval out, it's still showing 20 milliseconds. So you just need to keep in mind for using this Ethernet IP, this for free, this feature. So basically your data update would be equal or higher than 20 milliseconds. If in case you need a faster this communication update time, probably you have to purchase the hardware I talked in the previous video. This 266IF-02, this PROFINET module from YASKAWA. Alright, this is the topic for setting up the Ethernet IP communication between Siemens and YASKAWA MP3300. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.